Exam number 1, preparation. Use methods discussed in class lessons to solve the following problems. Notes are not allowed, and all work must be clearly shown. A non-graphing scientific calculator is okay. Here we want to solve the following equation. First thing we want to do is remove parentheses, so we can use the distributive property here and here, which will give us 4x minus 8 minus 10x minus 15 equals 7 minus 5x. Combining like terms here, we get negative 6x. Like terms here combine to get negative 23. And now we want to get all of our x's on one side of the equation. I'm going to choose to add 6x to both sides. This gives us negative 23 equals 7 plus x. Subtracting 7 from both sides gives us negative 30 is equal to x, and that is our answer. In the next problem, we have a fraction. The best thing to do when you have a fraction is get rid of the fraction by multiplying both sides by the least common denominator. The least common denominator here is 3. So what I can do here is multiply the left side of the equation by 3 and the right side by 3. Distributing the 3 here is going to cancel the 3, giving us 2x plus 4. Distributing the 3 here gives us positive 6. On the other side, distributing the 3 to each of these will give us 30 minus 3x. Combining like terms here, we have 2x plus 10 equals 30 minus 3x. Next, what I'm going to do is add 3x to both sides. This gives us 5x plus 10 is equal to 30. Subtracting 10, and now we have 5x equals 20, and the final step is to divide both sides by 5, which gives us x equals 4. In the next equation, we have a quadratic equation. We can try to solve this quadratic equation here by factoring. First of all, you want to make sure you have 0 on the other side. So we'll go ahead and use the magic x method. Multiplying 3 and negative 6, we get negative 18. The middle number is positive 7. And we're looking for two numbers that we can multiply to get negative 18 and add to get positive 7. And those two numbers are 9 and negative 2. So to start the factorization for this, we're going to put down x plus 9 and x minus 2 using these two numbers. And then remember, when you have a leading coefficient other than 1, you have to divide each of these numbers by that number. So this becomes x plus 3. And here I cannot divide or reduce, so the trick is to take this 3 and move it in front of the x. And that is the factorization. Keep in mind that this was equal to 0. And so now to solve this, we are going to set each factor equal to 0. And solving for x, we get x equals negative 3. And in the next equation, we get x equals positive 2/3. In the next problem, you can try factoring, but this actually does not factor. So if you want to take a minute to try to factor it, to convince yourself that it doesn't factor, go ahead and do that. Because it doesn't factor, what I'm going to do is use the quadratic formula. The quadratic formula says that if you have ax squared plus bx plus c equals 0, then x is going to be negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So for us, x is going to be negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is positive 13, all divided by 2 times 1. Simplifying, we have 4 plus or minus the square root of 16, take away 52, all divided by 2. Subtracting 16 and 52, we end up there with the square root of negative 36. And remember, the square root of negative 36 is 6i. So we have 4 plus or minus 6i divided by 2, and then dividing each one of those by 2 will give us 2 plus or minus 3i. In the next quadratic equation here, again, you can try factoring. I will tell you that factoring doesn't work. So we can either use the quadratic formula or completing the square. For this one, let me complete the square just to remind you of that technique. So we're going to have x squared minus 6x. I'm going to add 15 to both sides. So we're going to move this over to the right-hand side. And then when you complete the square, we are going to take the middle number here, which is negative 6. We're going to divide that by 2, and we're going to square it. And that is the number that we add to both sides. Now, negative 6 divided by 2 is negative 3, and when you square that, you get positive 9. So what we have on the left side is x squared minus 6x plus 9, and on the right side, we have 15 plus 9. Now, on the left-hand side, we can factor that into x minus 3 quantity squared, and on the right-hand side, we have 24. Next step, we are going to now take the square root of both sides. So on the left-hand side, we have x minus 3. Actually, technically, we're supposed to have absolute values here, but we can get around that by making sure we put a plus or a minus on the other side, and the square root of 24 simplifies to 2 times the square root of 6. Last step, we're going to add 3 to both sides, and this gives us x equals. And when you add this number here, the easiest way to do that is just put that number in front of the plus or minus there. So we have 3 plus or minus 2 times radical 6. In the next problem, you'll notice that it is a higher degree equation, but it very much has the same format as a quadratic equation like you see here. So for that reason, I am going to try to factor this. And this is factorable because we can use factors 8 times 3, which is 24, and 8 plus 3 is 11. So if we go to factor this, we're going to have x squared minus 8 times x squared minus 3. Now to get the solutions here, we are going to set each of these factors equal to 0. And then we're going to solve these equations. So in this first equation, I'm going to add 8 to both sides, and then I'll take the square root of both sides, and that gives us x equals plus or minus the square root of 8, which simplifies to 2 radical 2. In the other equation, I'm going to add 3 to both sides, and then take the square root of both sides, and this gives us x equals plus or minus the square root of 3. In the next equation, we have a radical, and the easiest way to deal with the radical is usually to get the radical by itself. So I'm going to subtract 2 from both sides. This will give us the square root of 3x plus 4 is equal to x minus 2. And now I'm going to square both sides, because when you square the radical, that's going to cancel it out, which will give us 3x plus 4. And then on the other side, let's keep in mind that x minus 2 squared means x minus 2 times x minus 2. And when you multiply that out, you're going to end up with x squared minus 4x plus 4. Notice now you have a quadratic equation. So I'm going to subtract 3x and subtract 4 from both sides to make the left-hand side 0. And on the right-hand side, notice that we get x squared minus 7x, and then these terms here end up canceling out. So now to solve for x, I can factor by taking out the greatest common factor there, which is x. And now I'm just going to set each one of those factors equal to 0. And we get x equals 0 and x equals 7. Now you need to check these answers, because sometimes when you solve an equation by squaring both sides, one or both of your answers may not work. So when we plug in x equals 0, into the original equation, you'll notice that you get the square root of 4 plus 2 equals 0. And this means 2 plus 2 is 0, and this is clearly not correct. So 0 is actually not an answer, so we're going to cross that out. Let's also check x equals 7. So if I plug in 7, I get the square root of 3 times 7 plus 4 plus 2 equals 7. This is the square root of 25 plus 2 is 7. And that is 5 plus 2 equals 7, which is correct. So in this problem, the only answer is x equals 7. In the next problem, we have a rational equation. So first thing you want to do when you have a rational equation is factor the denominators. So this denominator here will factor into x plus 3 times x minus 1. The second denominator is already in factored form. And so now we can see the least common denominator is x plus 3 times x minus 1. So I'm going to multiply the left-hand side by x plus 3 and x minus 1. And I'm going to multiply the right-hand side by x plus 3 and x minus 1. Now, when you multiply this to here, this is going to cancel out, leaving you with just 1. When you multiply it to here, x plus 3 will cancel, but you will have x minus 1 multiplied by 4 left over. And on the other side, I'm just going to multiply this out, which gives us x squared plus 2x minus 1. Now we have 1 plus 4x minus 4 is equal to x squared plus 2x. Should be minus 3. Sorry about that. Made a mistake there. And on the left-hand side, we have 4x minus 3 equals x squared plus 2x minus 3. This is a quadratic equation, so we're going to subtract 4x from both sides. And we're going to add 3 to both sides to make the left-hand side equal to 0. And now we're going to factor out the common factor, which is x. And finally, we'll set each one of those factors equal to 0. And we get 2 solutions, x equals 0 and x equals 2. In the next equation, we have an absolute value. First thing you want to do in an absolute value equation is get the absolute value by itself. So if we add 5 to both sides, we get the absolute value of 3x minus 2 is equal to 18. Now, the only way this can be true is if 3x minus 2 is 18 or 3x minus 2 is negative 18. Please do not try to solve for x before you remove the absolute values. So we're using the definition of an absolute value to write this. Now we can easily solve both of these. In the first equation, we get 3x equals 20, which means x is equal to 20 over 3. And in the second equation, we get 3x is equal to negative 16, which means x is negative 16 over 3. In the next problem, we just have a linear inequality. We have 1/3 x minus 6 is greater than or equal to 4x minus 1. To solve this, first of all, I'm just going to get rid of the fractions because when you don't have fractions, everything is a little bit easier. So 3 times 1/3 x is x. 3 times negative 6 is negative 18. On the other side, 3 times 4x is 12x, and 3 times negative 1 is negative 3. Now, when you're solving an inequality, it's always best to get your x's on the left-hand side. So when I subtract 12x there, I get negative 11x minus 18 is greater than or equal to negative 3. Next, I'm going to add 18 to both sides, which gives us negative 11x is greater than or equal to 15. And the last step, to solve for x, I need to divide by negative 11. And I'm doing this in red because you need to remember when you divide by a negative, you have to change the inequality symbol. So final answer should be x is less than or equal to negative 15 over 11. On a number line, that would be all the numbers to the left of negative 15 over 11 and including. And so finally, in interval notation, we can write that answer like so. Next, we have an absolute value inequality. To solve this, when you have an absolute value is less than a positive number, we need to know that that means that the number inside the absolute value, which in this case is 2x minus 5, can only be in between negative 17 and positive 17. So go back to the lesson video on this if you need more information. But now to solve it, we're just going to add 5 to everything. And that gives us negative 12 less than or equal to 2x less than or equal to 22. And then I'll divide everything by 2. And that gives us negative 6 less than or equal to x less than or equal to 11, which on a number line means that you need all of the values of x that are in between those two numbers. And so in interval notation, it is all the numbers between negative 6 and positive 11. In the next problem, it's very similar. We do need to isolate the absolute value first. So I'm going to subtract 1 from both sides, which gives us negative 2 times the absolute value of 5x minus 1 is less than negative 18. And then we do need to divide both sides by negative 2 here. That will give us the absolute value of 5x minus 1 all by itself. Negative 18 divided by negative 2 is positive 9. But remember, you have to switch the inequality symbol when you divide by a negative. Now, the procedure for this problem is different than the last problem because here we have greater than. So if the absolute value of a number is greater than 9, the only way that can happen is if that number itself is bigger than 9. So in this case, 5x minus 1 is bigger than 9. Or the other way it can happen is if the number is less than negative 9. And you have to set up two separate statements for this. After that, we can solve this fairly easily. We get 5x is less than negative 8. And that means that x is less than negative 8/5. Or the other solution here, we have 5x is greater than 10, and then dividing by 5, we get x is greater than 2. So on a number line now, if x is less than negative 8 over 5, it means we're over here. And if x is greater than 2, we're over here. And so in interval notation, here is our answer. All right, in the next problem, we have a fourth degree polynomial equation. So basically, we're trying to find the zeros of this polynomial. To do this, we're going to use synthetic division. So let's set up the problem. We're going to put our guess in the box. And then up here, we have coefficients, 1x to the fourth, negative 1x cubed, 3x squared, negative 9x, and negative 54. And for our first guess, I always like to start by guessing x equals 1 because it seems to work quite often. Not always, but quite often. But remember, you're only going to guess numbers here that are factors of 54. So let's try 1. 1 times 1 is 1. Negative 1 plus 1 is 0. And then 1 times 0 is 0. 3 plus 0 is 3. 1 times 3 is 3. Negative 9 plus 3 is negative 6. 1 times negative 6 is negative 6. And that gives us negative 60. And so this didn't work, right? Because we're looking to get 0 here, and we did not get 0. So we just have to guess another number. So you could try negative 1, or you could go to the next positive factor of 54, which would be 2. So let's try 2. 2 times 1 will be 2. Adding, we get 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. Negative 9 plus 10 is 1. And 2 times 1 is 2. And adding, we get negative 52. So again, we were unsuccessful, okay, because we did not get 0 here. But I'm showing you like this because this is typically how it will work when you try to solve the problem yourself. You're not always going to guess one of the correct answers on the first try. So let's keep going. Let's try negative 2. And let's go ahead and go through it. So negative 2 times 1 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 times negative 3 is positive 6. 3 plus 6 is 9. Negative 2 times 9 is negative 18. Negative 9 plus negative 18 is negative 27. And negative 2 times negative 27 is positive 54. And now when I add those, I get 0. So we have found one solution, but there are others. So what you can do now is you can continue with synthetic division on this polynomial, but you can also keep in mind that what you've basically done when you found out that negative 2 works is you now know that this original polynomial factors into x plus 2 times x cubed minus 3x squared plus 9x minus 27. So again, I could use synthetic division to find the next 0 of this polynomial, or I can factor this polynomial, in this case, by grouping. So I want you to see that if I group the first 2 terms and the last 2 terms of the polynomial, in the first 2 terms we can pull out x squared, in the last 2 terms we could pull out 9, and I want you now to see that you have a common factor of x minus 3 and x squared plus 9 left over. So this polynomial here factors into x minus 3 times x squared plus 9. And then, of course, don't forget you still have the factor x plus 2 from above. So now I have this pretty much factored, not completely factored, but almost completely factored. Setting this factor equal to 0, we're going to get negative 2. Of course, we already knew that. Setting this factor equal to 0, we're going to get positive 3. And the last solutions are going to come from setting x squared plus 9 equal to 0, which we can solve by subtracting 9 and then taking the square root. And of course, this gives us x equals plus or minus 3i. So we have 4 solutions to this equation. All right, so this problem is pretty much just like the last one. I'm going to set up my synthetic division process. And again, I always like to start by guessing 1 because 1 is a factor of all numbers. 1 times 2 is 2. 1 times 7 is 7. 1 times 2 is 2. 1 times negative 3 is negative 3. And adding here, we get 0. So we have success on the first try. Now that means this original polynomial, you could factor it like we did last time. But I want you to notice that this does not lend itself to factoring by grouping because we don't have a pattern of numbers like we did in the previous example. So for that reason, I'm just going to continue with the synthetic division process, and I'm going to guess negative 1 next. So let's see, negative 1 times 2 is negative 2. Then we get 5. Negative 1 times 5 is negative 5. And we get negative 3. And negative 1 times negative 3 is 3. And adding those, we get 0. So we have success. So now we know this thing factors into x minus 1, x plus 1, and then 2x squared plus 5x minus 3. And we could find the final solutions by simply factoring this polynomial here. And you can use a magic X to do that if you like. I'm just going to go ahead and put down the factorization here. But if you factor that one, you should find that it's 2x minus 1 multiplied by x plus 3. So setting all of these equal to 0, you're going to find that your solutions are x equals 1, x equals -1, x equals 1/2, and x equals -3. In this next problem, we have a rational inequality. To solve a rational inequality, first thing you want to do is make sure you have 0 on the other side, which we do. And now what I'm going to do is factor the numerator and the denominator of that fraction. And then we're going to set all of these factors equal to 0 to find our important numbers. And those numbers are going to be 5, -1, and -3. Next, we're going to draw a number line, and we're going to put these numbers on that number line. And we're going to test each one of these intervals. So I will use test numbers -10, -2, 0, and 10. Now what we're going to do is take all of these test numbers and plug them into the factored form to see if it gives us something that is true or false. So let's start with testing -10. So when I plug -10 in for x, we get -10 minus 5, -10 plus 1, and then divided by -10 plus 3. Is that less than 0? Well, that's -15 multiplied by -9 divided by -7. Is that less than 0? Yes, it is, right? And the reason it's less than 0 is because a negative times a negative divided by a negative is a negative, and a negative is always less than 0. So x equals -10 works, which means that this interval is part of our solution. Now we're going to do that for the other test numbers. So when I test x equals -2, again, I'm going to plug that in for x here. -2 minus 5 is -7. -2 plus 1 is -1. And -2 plus 3 is +1. Is this less than 0? And the answer is no, because a negative times a negative is a positive, and a positive is not less than 0. So -2 is not a solution, which means none of these answers in this interval is a solution. Next, let's do that for x equals 0. When you plug in 0, you get -5 times 1 divided by 3. Is that less than 0? Yes, it is, for the same reasons I've talked about. So that means that this interval is a solution. And finally, when you plug in x equals 10, you are going to get 5 times 11 divided by 13. Is that less than 0? The answer is no. So this is not a solution. So in the end, our final solution here is all the numbers from -infinity up to -3, not including, union all the numbers from -1 up to 5. All right, for the next problem, it's pretty much the same thing, except it's actually a little bit easier because we just have a quadratic here. Again, make sure you have 0 on the other side. First step is to factor. So we have x minus 7 times x plus 3 is greater than or equal to 0. Next, we're going to set those factors equal to 0 to find our important numbers here, which are going to be 7 and -3. Let's graph those on a number line. And then let's go ahead and pick test numbers. So a number to the left of -3 is -5, for example. A number in between here will be 0. And a number to the right of 7 will be 10. And then just like you did in the last problem, you're going to take these numbers, plug them into here, and test to see if it's true or false. What you will find is that this is true, and this one is false. And so our solution is going to be these values of x, which in interval notation is all the numbers from -infinity to -3, and we are including, and then all the numbers from 7 to infinity also including. And the reason we're including is because we have greater than or equal to. Next, we want to find the equation of the line passing through the point -2, 5, and perpendicular to the line 2x minus 5y equals 10. So let's start with the line that it's perpendicular to. If we solve for y in this line by doing what I'm doing here, we end up with y is equal to -2 plus 2/5 x. Or we can say y equals 2/5 x minus 2. So the slope of this line is 2/5. But remember, we're looking for the equation of the line that is perpendicular to this line. So the slope of the line that we're interested in, which I'm going to call m perpendicular, that slope has to be the negative reciprocal of 2/5, and that is -5/2. So the slope of our line is -5/2, and it's going to pass through the point -2, 5. And so now we can just use the equation of a line. And I like this formula for the equation of a line. And we're just going to plug these things in. So we have y minus 5 equals -5/2 times x minus -2. This is y minus 5 equals -5/2 times x plus 2. Or y minus 5 equals -5/2 x minus 5. That's what you get when you distribute here. And finally, if I add 5 to both sides, I get y is equal to -5/2 x, right? Because when I add 5 to both sides, it cancels out. So that is the equation of the line that is perpendicular to this other line and passes through the point -2, +5. Next, we want to find the center and radius of the circle given by this equation. So what we need to do, of course, is put this circle in standard form, which means it needs to look like this. So to do that, I'm going to take my x terms and group them together, leave a little space, and then we'll take our y terms here, group them together, also leave a little space, and the -15, I'm going to add 15 to both sides to move that over to the right-hand side. Next, I'm going to complete the square. So half of this number is 3, squared is 9, so I'm going to add 9 to both sides. I'm going to complete the square here as well. Half of 10 is 5, and 5 squared is 25, so I'm going to add 25 to both sides. This will allow us to factor this first one into x minus 3 quantity squared, plus we'll factor the second one, y plus 5 quantity squared, and on the other side we have 49. So now it's exactly in this format, and so the center of this circle is going to be +3, -5, and the radius, well, the radius is not 49, it's the square root of 49, which is 7. So remember, 49 can be written as 7 squared, and r is the number that's being squared there. Now to sketch a graph, basically you just graph the center, +3, -5, and then we are going to use the radius equals 7 to go up 7, down 7, to the right 7, and to the left 7, and then we're just going to sketch a graph through those points. And that's just a rough sketch, and that's all we need. Next, let's find the domain of this function. So the important thing to remember is that when you have something inside of a radical, it cannot be negative when you're talking about functions. And also when you have something in the bottom of a fraction, it cannot be 0. So 4 minus 5x, which is the thing inside the radical here, must be positive. It must be strictly greater than 0. So let's just solve for x to see what x would be. So we get -5x is greater than -4, and then dividing both sides by -5, we get x is less than 4/5. This is our domain, okay? So if x is less than 4/5, it means that x can be any number from negative infinity up to 4/5. Here we want to graph the function f of x equals 2x squared plus 4x minus 3, and then find the domain and range. So to graph this, it's best to realize that this is a parabola, and so we need the vertex of this parabola. We can find that by either completing the square or by using the formula x equals negative b divided by 2a. This method is a little bit easier. So negative b is going to be negative 4 divided by 2 times a. A is 2, so that's going to be 2 times 2. That's negative 4 divided by 4, which is negative 1. And then the y-coordinate of the vertex can be found by taking the x-coordinate and plugging it in. So we're going to have 2 times negative 1 squared plus 4 times negative 1 minus 3. This is 2 times 1, which is 2, minus 4 minus 3, which is negative 5. So the vertex is negative 1, negative 5. Okay, now that's the vertex. Now how do we find the domain and range? Well, actually drawing the graph is going to help us find this domain and range. So the vertex is negative 1, negative 5, which is down here. Now if you plug in a couple of other points, so if you just plug in, for example, let x equal 0, let x equal negative 2, you can find very easily a couple of additional points on this graph. And what you'll find is that you have a point here and a point here, and then we know that the graph must do something like this, right? Because it's a parabola, okay? Now from there, we can state what is the domain. Well, of course, the domain is all real numbers, right? You can plug any number into a second-degree polynomial function. But the range is where the graph really comes in handy, because the range is the y values. And you can see on this graph, the lowest y value that you get down here is negative 5. So the range is going to be all the y values starting at the bottom, starting at negative 5 and going up to infinity. Next, we want to find the difference quotient for this function. Let's remember the difference quotient is f of x plus h minus f of x, all divided by h. So f of x plus h means that we are going to plug x plus h in for x there. So if I plug x plus h into here, I get 2 times x plus h squared. Plus, if we plug in x plus h there, we get plus 3 times x plus h. Minus, then we have to subtract f of x, which is 2x squared plus 3x. And when you subtract that, it needs to be in parentheses. And this is all divided by h. So now we just need to simplify. This is 2 times x plus h times x plus h plus 3x plus 3h minus 2x squared minus 3x, all divided by h. So we just need to multiply this out. So you get x squared plus 2xh plus h squared, and then it's also multiplied by 2. So that's going to be 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 2x squared minus 3x, all divided by h. Okay, so once you have it all multiplied out, now we look for what we can cancel. So notice that you have positive 2x squared and negative 2x squared, and you have positive 3x and negative 3x. So what you have left over on top is 4xh plus 2h squared plus 3h, all divided by h. And now we can factor out an h on top. And the reason we factor it out is because we can cancel it with the h in the bottom. And our final answer here is 4x plus 2h plus 3. And that is the difference quotient. And finally, we want to find g of f of x and its domain. So g of f of x, let's remember that we are really plugging f of x into g. So we're going to take this function here and plug it in for x here and plug it in for x here. So that's going to give us 2x squared minus 3x on top, and in the bottom 2x squared minus 3x minus 2. And that is our function. Now, can you simplify it? Well, you could try factoring it. So on top, you could factor out an x, and you could say 2x minus 3. And in the bottom, you actually can factor this, I believe. Let's try. So, yeah, I believe we can factor it like that. But factoring it doesn't really produce anything that can be canceled. So you could say the answer is this. You could keep the original, or you could say it in factored form. Okay, so that is g of f of x. Now, what about its domain? Well, its domain clearly has a couple of numbers that are not allowed, because 2x plus 1, if that's equal to 0, we're going to have a problem, right? Because we cannot divide by 0. And so that means that x equals negative 1/2 is a restricted value, because that will make that factor 0. And if x minus 2 equals 0, that would mean that x would be 2. So we have to restrict 2 as well. So our domain is all numbers except for these two numbers. So that's going to be negative infinity to negative 1/2, union negative 1/2 to 2, union 2 to infinity. Okay, and that's how we write our domain in interval notation. The other really easy way to write our domain is you could just say all x except x cannot be negative 1/2 or 2. All right, and that concludes this exam 1 preparation. Good luck, everybody.